In Essential Task 7.2, we are going to take the principles established in 7.1 regarding classical conditioning and identify two real-life examples that apply those basic principles. This concept map is only the one box that you see here under Applications, so you could easily hold your piece of paper vertically or horizontally. I will allow you to pause the video here, though, before proceeding into the concept map. In Essential Task 7.1, we established the basic principles outlining the process of classical conditioning, indicating that some responses are learned automatically through what we called the classical conditioning flowchart. For example, Pavlov's dogs learn to automatically salivate to the sound of a bell. In the Watson Baby Albert study, Baby Albert learned to automatically exhibit a fear response around the presence of animals. In today's Essential Task, we are going to talk about the types of behaviors that are easily learned through classical conditioning, because not all behaviors can be taught or learned through classical conditioning. Some behaviors are more likely to undergo the classical conditioning process than others. We call some of those biological dispositions. This acknowledges that organisms are more likely to develop a conditioned response to behaviors that enhance survival. Conditioned response, as indicated there with that italic blue, is the abbreviation CR from the flowchart that we established in 7.1, specifically the CR that appears in the bottom right corner. There's only one location within the flowchart where you see the CR. The conditioned response is the new behavior that is learned in response to the presence or the presentation of the conditioned stimulus. The conditioned stimulus was the stimuli that was at one point in the scenario neutral. So, for example, using Pavlov's dogs and the bell eliciting salivation, organisms in that case would be more likely to learn to salivate to the sound of a bell. Why? Because eating enhances survival. So it would make logical sense for some behaviors that in that context enhance survival to be taught through classical conditioning. There are two common examples, though, that fall under the category of biological dispositions. The first was studied by contributing psychologist John Garcia. John Garcia, while studying radiation in mice, something sort of unrelated to the topic of classical conditioning, discovered that the mice seemingly learned to avoid foods that produce some type of negative response, specifically nausea and vomiting. What he essentially indicated was that if there is a very clear negative conditioned response, whether it's to a food or to a beverage, organisms, whether it's mice or people, are more likely going to avoid that food going forward. Why? Because avoiding foods that make you sick in some capacity will probably enhance survival. If we think back thousands of years, if there is a mushroom within your environment that you could eat, but would at the same time make you sick, you're probably going to avoid it in the future. That's an example of a phenomenon called taste aversion. This is a phenomenon that you have to be very keenly aware of because you can, in some cases, accidentally experience classical conditioning when eating something that you really like. For example, if the cheese in your refrigerator went bad, but you use that cheese to make a pizza, and now all of a sudden after you eat that pizza, you get sick, you might undergo taste aversion, where every time you look at pizza, all you do is experience the nausea that you associated with that one experience of eating bad pizza. Maybe one day you're sick and you've been vomiting and throwing up all day, but you decide to eat your favorite food thinking that it's going to be comforting. Well, unfortunately, if you eat that food and then an hour later throw up, you might undergo classical conditioning where you associate that negative experience of throwing up with your favorite food, that favorite food at one point being neutral. You undergo classical conditioning, and now in the presence of that food acts as a conditioned stimulus, which might elicit automatically, outside of your control, a conditioned response of nausea. So the taste aversion phenomenon is an example we went over in class, but there is a specific term that we use to associate when classical conditioning occurs in the context of food. The other common example of a biological disposition, a behavior that in some capacity enhances survival, is a term that you likely have some prior knowledge regarding, which is the term phobia. By definition, a phobia is exhibiting an irrational fear and an irrational avoidance of a specific stimuli. The concept of classical conditioning does a great job of explaining how phobias are developed. For example, let's say for your entire life, dogs have been totally neutral. You've never owned one, but you've never particularly feared one. If you have a singular event where, let's say, for example, the dog bites you, you could very easily undergo classical conditioning, where the dog was once neutral. Being bitten by anything is obviously going to elicit a fear response or pain. And if you undergo a pairing process where you take the dog and you take the experience of being bitten, you're obviously going to feel pain or exhibit fear. At the end of that, in the final stage of that flowchart that we talked about in 7.1, the dog in and of itself, which was once neutral, might be powerful enough to elicit a fear response. Why? You underwent classical conditioning. You developed a conditioned response, which is the bottom right corner of the flowchart, of fear or anxiety in response to the presence of a dog. That very basic 3-step process can very easily explain not only how we avoid foods, but how we develop phobias.